Hey guys, Tim here, Big Dog Forge. How you doing? I'm glad you could stop by and check it out. We're out of the office today. It's not in the mood to be sitting around. I've got too much to do, and I thought I'd bring you guys out here for a little bit into the shop. So after the 1,000 layer challenge and doing a couple of other projects, it kind of took its toll on the little forge, and I got to do something about it. So what I'm thinking is, here, let me show you. Let's take a look at this real quick. So what you're seeing is the result of way too much. Hang on a second, let me grab a flashlight. You can see this a little better. Alright, I'm back. So anyway, you can kind of see inside there. Maybe. And this is a result of just use after use of forge welding and using a half a box of flux to do the 1,000 layer challenge. And the little forge still gets up to temperature, surprisingly. And I actually just did some welding in it a day ago, but it's just taking a toll on it. And all that black goo down there is basically borax turned into molten glass, and it just hard. So this all needs to be pulled apart. So what I need to do is get myself a second forge online so that we can do some forge welding, because Damascus is going to continue to be a thing. And so what I've decided to do, let me walk you over here real quick, take a little stroll, is we pulled this guy out of storage. And it's something I got for free some time ago. It's an old forge. It came out of a high school around here when they used to actually teach, metalworking, blacksmithing. You don't do that anymore. It's all about, I don't know, arts, I guess. So anyway, this guy is all casted, like castable refractory cement on the inside, and he's got some problems here and there. The roof has got some cracks and holes and crap like that in it. So I may reinforce this with some mesh and cast over it, and then just reline it with some KO wool and some ITC 100, and this would just be a forge. I wouldn't do any welding in this one. This would just be a daily thing, so the temperature wouldn't get too hot. But it's an old natural gas burner thing, and I'd have to change that to propane, so we'd probably come right in the top right here with a and then patch this up, or may end up rebuilding an entirely new hood for it. I don't know. Get rid of this hole, patch this, and then cut a new hole back there for a burner to go straight in. But I need to do this before I can move forward. I've got a lot of tongs to build, and I've got a lot of subscriber requests, things like that to do. So I think that this is going to be our guy for our daily forging, and then we'll rebuild the other guy for our welding forge. And I got some other ideas. And this guy right here, a little swing open kind of a portal in there, and we've still got that guy. He needs to be reattached, and I think there used to be a handle on here, and this used to be lined with refractory, and we just put some KO wool in there. Anyway, I think it's workable, I think it's doable, but it's going to take a little bit of work. But I think what the first step's going to be is that I want to try to build a burner that'll actually work with this thing. Of course, the cavity is going to get, the inside of the forge will get smaller if I repair this and then line it with KO wool with mesh behind it. But we'll see. We'll figure that out as we go. Like we do everything, we just kind of make it up on the fly. All right. So what we're going to do is build a burner for this guy. All right, let's get going. So I saw these burners that Alex Steele is selling. They're out of Australia, I think, and they're from a company called Gameco, Artisan Supply, I think. Anyway, I kind of like the way it looked. He did a little video on how it went together, that kind of thing, and I got some ideas from that. And I think I'm going to try to kind of replicate something like that. They're a little expensive, and since I've got the tools, I figured, I can make one. So we'll see what happens there. It's all going to be guesswork because I really don't know things like gas inlet size, where that gas inlet sits in the air intake, the size of the air intake, the length of the pipe. I don't know any of that stuff. So it's all going to be just grab some stuff, go, and see what happens. Use my best guess. So let's give it a shot. See what happens. What's the worst that can happen? We start over and we learn something. All right. So, let's do it. See you soon. Thanks, guys. Bye.
Okay, guys, so we went to the hardware store and picked up some black iron pipe, and went to the junkyard and picked up a piece of stainless steel pipe, and that's going to be our inlet, our air intake, and it's a 3/4 to 1.5 inch bell adapter, and that's a 3/4 inch to 1 inch bell adapter, and that was going to be our flare. But I decided I wanted to use some stainless steel and do this right, and so I need to adapt that, fit onto that pipe, and it's a little bit loose. So what I think I'm going to do is go over to the lathe, and we're going to cut the bell off this thing and machine it down so it'll fit into the end of this pipe, and we can weld it in there. That way we can get a little bit bigger flare, and it'll be stainless steel. So you're going to see a whole lot of lathe work here. And no, I'm not a machinist. I picked this lathe up years ago. It's an old Colchester student. Yeah, I don't know, it's old. That's all I really know about it. And I'm not a machinist. I use it to turn things and just make parts by eye, pretty much. I have machined a few things on it. But so you guys that know what you're doing here, you can sit back and just kind of giggle if you want. So we're just going to sort of machine down the shaft below the 3/4 inch and right down into that bell and take that off. And we've got it on our 3/4 inch pipe. We're just going to clean this up. It'll be a little bit smaller than the stainless steel, move around, but we'll just center it up when we weld it on there. It won't be perfectly straight, but for what we're doing, it's all an experiment. We're just going to see how this goes. All right, so this is a piece of our stainless steel, and we're going to face the end of this thing and clean it up. So we have a nice welding surface. We're just going to MIG weld this together with mild steel wire. I've done this before with stainless steel, and it seems to work pretty well. Make sure there aren't any burrs. This pipe actually has a little seam going down the inside of it, but now we can weld that in there just like that. We're going to take some of that face off of it. It's got a little sharp, ragged edge. And we'll clean that up first. And that tool I'm using on that chuck is actually the one that came with this when I picked it up. It was in the back of a warehouse and been sitting for years and years. The thing works pretty well though. If I knew how to use it, it'd probably work a lot better. And we'll clean up the face of that, the inside of it, just to make it look pretty. And we'll weld that in there. Like I said, I'm just going to center this up sort of by eye. And we've got some more turning to do on this, so it's not going to be perfectly straight, but I don't think that it matters all that much. Alrighty, there we go. Now we made this a little bit long, so we're going to have to get it to the bandsaw and cut a little bit of that off there. And like I said, it's just eyeballing it through just what the picture looked like from appearances. A lot of guesswork into this. We'll see how she comes out. My focus is acting up there a little bit. A new camera. Need to figure out how to work it. I'm going to clean up the inside so we don't have any turbulence or too much turbulence in the airflow there coming out that end. And we'll take the burr down from the bandsaw a little bit. And you can see it's a little lopsided there. But that's okay. We're going to get it over the bench and grind that weld off there. We have to slide this down inside a collar. It's going to hold it into the forge. You know, any protrusions sticking out, interfering with anything. There we go. Little touch up. Nice. Okay, we're going to start working on the intake end. We got a little piece of 1/8 inch iron pipe that we're going to use as our injector. And we're going to clean up the outside of this bell because we're going to weld to it later on. And we need to face it so that we can make a nice sealing surface. We're going to put a, I guess they call it a choke on this thing. It's a plate that sits down on top to choke the air off. So you can have a nice fine air adjustment. And we'll clean up those corners. A little sandpaper on there. Alrighty. Nice clean face on that thing. Nice welding surfaces on the side. Alright, so this could be our choke plate. And we just grabbed a piece of 1/4 inch. It's cold rolled steel. Take over the bandsaw and cut that circle out kind of rough. And we'll redraw our line so we know where we're going to. And we'll get this into the vise and we'll grind off most of it. I was going to use a plasma cutter on this thing, but it's kind of a small circle. I really didn't have a way to make a circle that was close enough, so I figured out what the heck, I'd just use a grinder. And then once we get these peaks knocked off, most of this stuff with this heavy disc, we'll get it over to the belt sander and we'll grind down to that line as close as we can. And we're going to get it that way so we can eventually get it into the lathe and make it nice and pretty. It's going to have to be a little smaller than the lip of that bell adapter that we fitted it for. There we go. And that table on that belt grinder worked out really well for this. Kept it nice and flat, made a nice edge, and I was able to grind right up to that felt marker line. And it took a minute or two, but came out pretty good. There we go. And we get this thing over to the lathe now that it's sort of semi-round. And you can see the front of those jaws. They've got just a slight recess in them. I use them for holding this sort of thing. I think that at one point somebody used that to probably redress those jaws with some sort of a line boring thing or something. But I use it to hold discs. Works pretty well. So we're going to drill a hole in this thing. And we're going to tap it for our 1/8 inch black pipe. But that won't be the final thread pattern in this thing. We're doing this as a tool. We're going to thread a piece of pipe in this thing so we can use the pipe to hold it in the jaws, so we can turn the outside down and make it nice and round and even. Keep this thing as uniform as possible. There we go, there's our pipe thread for our 1/8 inch pipe. We'll see how that fits in there. Alright, we're going to spin it around, and now we can dress up the edges of this thing. And we had to take a little bit of it off. Took probably a 1/16 of an inch or so off. You know, maybe not quite that much. Dressed up the nice little corners there. I want it to sit about a 32nd of an inch shy of the outside of that bell adapter. Alright, so now we got it dressed up. Nope, not going to come off that way. Let me get it clamped back in there and get some vice grips on this thing. See if we can get that pipe out of there. Kind of tightened up while we had the tool on it. There we go. So we're cutting it for a 7/16 by 20 thread. The reason we're doing this is because this thing has to move up and down a shaft for adjustment. And we're going to use another piece of 1/8 inch pipe. Get her cleaned up here. And we're going to thread the outside of that piece of pipe with a 7/16 20 thread. And we'll keep the pipe threads on either end. There you go. I didn't show threading that thing. I think I got involved and forgot about filming it. I don't know. So this little cap is going to be where our injector adapts to. And what we're going to be using is a MIG welding tip. They're made out of copper. And we're going to use a 023 wire welding tip as our little orifice for the gas inlet. Alright, we give ourselves a little center there. Drill this out. And we get our tap in there. And this is a 1/4 20 tap, and those things actually have a little bit different thread pattern, but I ended up retapping the end of the MIG tip to fit this 1/4 20 because it's what I had, and it worked out pretty well. There we go. Alright, we need to get some uprights welded on this thing. Set all of our other pieces aside for the moment. Now these are just mild steel, and I made them probably about twice as long as they needed to be, but I just wanted to make sure I had enough room to work with it. When you're experimenting, you give yourself as much wiggle room as possible. And in the end, I'm kind of glad I did. I need to make these uprights as even as possible, as square as possible. And I couldn't find my little machinist square, so we're just going with the old carpenter's quick square here. And get that splatter off there. So have a nice sealing surface. And that's where our disc is going to go. Alright. This will bridge the uprights. And once this guy's all assembled, we're going to get him back into the lathe again. And that bridge across the top will be drilled and tapped for our pipe that's been threaded on the outside for a 7/16 20. There we go. They're all tacked up. I clean some of these corners off. I'm going to spin this in the lathe, and I prefer to do it without too many sharp corners on it. And it'd make it look a little nicer. A little more finished. We're going to go through the trouble to do this thing. If it works, we might as well do it right. Or learn from our mistakes. Whichever. Alrighty. There she is. Alright, so into the lathe with her. And again, we're going to drill and tap this thing for 7/16 20, which is what the outside of our pipe is. I think I've said that 6 times already. Alright, we'll just power tap this thing real quick. So doing all this in the lathe ensures that my injector, my orifice, my inlet, is going to be aimed directly down the center of that pipe. And from what I understand, that's the best thing to do. Okay, we got a nut. It fits our thread pattern. Screw that on. And we're going to get our plate up onto this guy. Oh, hold on a minute. I got to put our inlet in there. Alright, get out the pipe dope. And this is pipe dope rated for gas. Everybody says not to use Teflon tape. And I actually did have an experience where the Teflon tape, small piece broke off and got stuck inside the little injector and clogged it up on the other forge. So I use this now. It eliminates a lot of problems. And I'll just grab a pair of pliers and tighten this guy up. There we go. I'm going to thread that down until that plate sits right on top of it and on top of that bell adapter. And we'll tighten that nut down, and that should lock it into place. There we go. Alright. Pretty good, pretty good. Looking schmancy. Okie doke. Let's get the flare screwed onto the other end of this thing real quick. Alright. And my old vice grips. I've got 6 pipe wrenches and I can't find one of them. So, man, we'll get her done this way. Alright. Let's put a little elbow on the top of this thing. So we can put a little brass adapter in there and hook it up to some gas. And back to the vice grips. Yeah, nice and tight. Okay. I like that.
Alright guys, well, we put her together. We're going to hook this thing up to some propane and see how it works out. Hopefully we don't blow ourselves up. I don't know. So let's take a little bit closer look here real quick. So I don't know if you can see or not that little injector gas inlet comes down to about here in this little bell, and I don't know exactly where it's supposed to be, if it's preferred to be up here or where, but that's where it is. And that was pretty much dictated by the length of this guy, the little nipple I put on there, and the MIG tip. So hopefully it'll work out. We'll see. And then we got a piece of brass in there. We can hook our propane bottle up to it, and we have a little needle valve on the propane bottle and a regulator, so we can regulate that. And then this guy goes all the way down to choke out the air, and it sits pretty flush. It sits pretty good, pretty flush, pretty flush. All right. And then down here is the flare, and this piece of black pipe is 12 inches long, and I think it probably could have been 10 inches long. I don't know. But we're going to hook this thing up, fire it up, and see what happens. and it could be a very exciting video. We're going to find out. All right, give me a minute and we get this thing on a tripod. Hey guys, I think we're going to call it a success. I think that the one thing that I would change is that air inlet, that MIG tip. I would probably change that to an 030. When you open up the air inlet too much, it tends to go out on you. And I think that, you know, I cranked up the regulator on it and it was still doing that. So it could probably use a little more fuel. But for what I'm going to do with it, I think it'll warm that forge up just fine once we get it rebuilt. And we're not going to take it up to welding temperatures anyway, so it's just going to be a daily forge. So, think we're good? Another one down. Thanks for watching, guys. Really appreciate it. And thanks for all you new subscribers, man. You guys are incredibly cool. That is just freaking awesome. And so we're going to get back to the regular blacksmith programming here pretty soon, as soon as we can. And just got a little shop maintenance to do. Happens. What are you going to do, right? So thanks for sticking with me. Appreciate it. Hope you enjoyed it. If you liked it, click the like, subscribe, share. Got to share. Sharing is caring. Come on. All right. All right. So thanks, guys. I appreciate the time. Take care. We'll see you next time right here at Big Dog Forge. Be safe. Bye-bye now.